electrons. मैं वो सारे previous lectures जो है ना वो मैं share भी कर दूंगा. So I'm going to continue with we'll just do past paper questions, ठीक है, these 2 days, and then hopefully on Monday पता नहीं we'll have Muharram, so probably on Tuesday or Wednesday we'll start with the next topic, ठीक है. But past paper questions related to electrochemistry. So starting with the worksheet. Did I send the worksheet? Well, अगर तो नहीं की, I'll just quickly send it. 1 second. Well, I've already sent it. No, I haven't sent it. Because I'm not this one. It's so ये क्या लगता है? एक second. So I'm just hold on 1 second. So I've sent. It's going. Okay. So you'll probably get it. Starting with the first one, draw a fully labeled diagram of the apparatus that would be used to measure the standard electrode potential of O2 in half equation 1 under standard conditions, including all necessary chemicals. And he's talking about half equation 1, which is this one. Okay, that's the equation that he's talking about. So वो कह रहा है कि how would you, and let me rewrite this equation. So the equation is 2H2O, and it's forming how many O2s? O2 plus 4H plus 1 plus as a plus 4 electron. Okay, so that's our half equation 1. As he's saying, how would you calculate the cell potential? First thing, it involves a gas. So you've got what you'll do is you'll construct an electrode, and it's going to have a gas jar. Okay, that's one thing. So there's going to be oxygen gas in that gas jar. Where will the H plus O ions? The H plus O ions will be added into the solution. So you'll have a beaker, and in that beaker you'll have H plus 1 ions, and they're going to be aqueous, and their concentration is going to be 1 mole per dm cube. You're going to mention that. You can remember it has to be properly labeled. This is about drawing electrodes. What else? Water is by default there, so you don't have to mention water, but you'll have to mention an electrode. An electrode has to be added, and it has to be an inert electrode, which will be made from platinum. That's the first part. Okay, so we've constructed the electrode, but he hasn't asked for electrode. He's asked you how would you measure the E naught. So how would you measure the E naught? Ye clear hai pehle? Abdullah, Abia, Umar, is this clear? This is how you're going to draw the electrode, right? It's oxygen gas, and H plus 1, and water. And now the next thing is, you would have to, so the question is about E naught, right? It's how would you measure the E naught? So what you'll do is you'll take a voltmeter. What would you connect the voltmeter with? All potentials are measured against the standard hydrogen electrode. So there's going to be another electrode, which is the standard hydrogen electrode. And in that electrode, there's going to be H2 gas. And there's going to be H plus 1 ions in the solution. Make sure that's H plus 1 aqueous, and it's 1 mole per dm cube, right? Or kya hoga? It's you have to add a platinum catalyst, right? So label that. This is your 0.00 volts. As he's not actually asking you, you just have to sketch one thing. There's one thing that's missing. What is that one thing that's missing over here? This could be labeled color. Okay, this is your standard hydrogen electrode. As anyways, the one thing that's missing is TK. That's your salt bridge. Exactly. So you'll draw a salt bridge and you're going to label that. And since he's talking about E naught, remember, be careful. The oxygen gas must be at 1 atm pressure, right? The hydrogen gas must be at 1 atm pressure, standard conditions. The solutions will be at 1 mole per dm cube concentration. That's pretty much it. You'll get 4 marks for this. Here, that's the first thing. And for the cell, use the data booklet to calculate the E naught cell and deduce which electrode is the positive one. Now, the hydrogen electrode I know is the 0 volt. I'm going to open the data booklet. Econ's equation, it's water and oxygen and H+1, right? So let's open the data booklet. Copy equations. So water, oxygen and H+1. Do we have water, oxygen and H+1? I think. So that's, and he's talking about it in the backward direction, right? Two water molecules turning into oxygen, H+1 and 4 electrons. It's 1.23 volts, right? So this one is 1.23 volts. So this one is 1.23 volts. So which one is your higher potential? Which one is the positive electrode? The positive is the higher one. So the 1.23 volts is the higher one. So identity of the positive electrode, it's the left one. The E naught cell is going to be 1.23 volts. You get 1.23 minus 0 volts. Ye bhi clear hai ye part? Alicia, is this clear? Shah Naseeb. So moving on, next one, we've got this equation. He's saying use data from the data booklet to predict whether the reaction is feasible when aqueous solution of iodide 5 ions, which is this one, acidified. So he's talking about this thing. Iodide 5 ions and bromide ions are mixed. Now, if you look at the data booklet, you won't find any equations for iodide 5. I don't think you will. Iodine kidhar hai? Iodine. So you don't, under I, you don't find any equation for iodide 5, right? So I guess that's the only equation. So the only equation for acidified iodide 5 is this one. That's the only one. वो कह रहे हैं bromide के साथ. So go in the data booklet and find an equation for bromide, which is so where's bromide? Bromide is over here. There's only one equation, which is this one, and it's 1.07 volts. So I'm going to use that. So that equation is Br2 plus 2 electrons in equilibrium with 2 Br minus 1. And the E naught for this is 1.07 volts. Now that is your higher E naught, right? So the high E naught is going to gain electrons. उसने वो arrow पहले ही बनाया था. It was moving forward, right? Because I guess he knew that was the higher E naught. This one is the lower E naught. It loses electrons. It's going to go in the backward direction, right? And that's it. That's your reaction. You just have to make the reaction. उसने कहा कि predict whether a reaction is feasible or whether it's not feasible, right? So we'll so what I'll do is, first thing, balance the electrons. I'm going to multiply this equation by 2, and I'm going to multiply this equation by 5. You can remember the electrons gain and loss, they have to be made equal. It's a 1 mark question. He never actually asked you to make an equation. I'm just doing it on my own. The only thing he asked was predict whether the reaction is going to happen. Well, it will happen. The bromide ions are the ones that are going to lose electrons, and the iodide ions are the ones that are going to gain electrons, right? But I'll make the equation anyways. Add up the reactants. The reactants one, so it's this and this, right? So it's 2IO3 minus 1 and plus 6 into 12H plus 1. And bottom bit there's going to be 10Br minus 1, right? And what about the product? In the first one, it's going to be I2 plus 6H2O. So it's going to be I2 plus. And in the bottom one, the product is 5Br2. So the reaction is happening. Iodide 5 is reacting with Br minus 1. Again, how do you know that this will happen? You'll calculate the E0 cell. The E0 cell has to be positive. E0 cell is the potential difference between the reduction potential, which is the high E0, which is 1.19, minus the oxidation potential, which is the lower one, which is 1.07. If you calculate this, this will come out to be 0.12 volts. ठीक है, ये clear है? तो आपने बताना है कि it's coming out to be greater than 0. Hence, it's feasible. Remember we talked about this. I told you that if the E0 cell comes out to be a positive value, that means the reaction will happen. Negative आ जाती है, उसका मतलब है कि the reaction is not going to happen because the voltage or the reaction will happen in the opposite direction, not in the direction that he was suggesting. So it's a 1 mark question. All you had to do was you just had to quote this, that the E0 cell is this and it's greater than 0, which is why it's feasible. ठीक है, ये clear है? और एक सेकंड देना मुझे. ये part clear है सारों को? जी बहना, Shian, is this clear? Clear है कि नहीं clear? As the next part, we've got as the next one is we've got this reaction. He's saying use the half equation to write the ionic equation for the electrolysis of Al2O3. So one equation is given, the reaction at anode. Now, if you know Al2O3, you know what happens at cathode. Cathode reduction happens and Al plus 3 gains 3 electrons to form aluminium, right? That is what's going to happen, right? So you have to make the overall equation. So you just add up the anode equation and the cathode equation. This one has to be multiplied by 3. And this one has to be multiplied by 2. Electrons gained and lost equal होने चाहिए, ठीक है? So it's going to be 3O minus 2. And it's plus 3C plus 2Al plus 3. And the product is going to be 3CO. And the bottom product is going to be 2Al. Okay, that's it, just 1 mark. The point Q is equal to IT. Again, saying aluminum oxide is electrolyzed for 3 hours using carbon electrodes and a current of this amperes. Calculate the maximum mass of aluminum formed. Now, in the electrolysis, this is what's happening. Al plus 3 gains 3 electrons to form aluminium, right? So the electrolysis is going on for 3 hours and the current is given. So how much charge flows through it? It's Q is equal to IT. If I do that, it's going to be 3 into 1 hour में कितने seconds होते हैं? That's 3600 seconds into the current, which is 3.5 into 10 to the power 5 amperes. So what value do I get for this? जरा बताओ ये क्या आ रहा है? क्या calculators किधर है? What do you get for this? So the value for this is 3.78 into 10 raised per 9, right? So 3.78 into 10 raised per 9 coulombs, right? What do we do with this? We use the Faraday constant. What is the charge on 1 mole of electrons? It's 96, 500 coulombs. So if there is 3.79 times 10 to the power 9 coulombs flowing through the circuit, so how many moles of electrons are actually going through that? So what is X? Well, X kya hoga unknown? X will be 3.79 times 10 per 9, and the whole thing gets divided by, the whole thing gets divided by 96 500 coulombs. How many moles do we get? So how many moles of electrons? क्या बने स्पीड में करो जरा जल्दी बताओ. Alicia, Abia, Anna. What's the answer to this one? Shian, कोई तो आंसर बता दे. ठीक है आ गया. So this one is 39170. So basic 39. Are you sure 391790, right? The 1 second 39170 or 39.27 into 10 power. Are these both the same thing? I think. So 39170 kar lete hain. So you're getting 39170 moles of electrons. That's a lot of electrons, right? So the moles of aluminium would be 3 times less, right? It's 3:1. So we'll find the moles of aluminium, which will come out to be 39170, 1, 7, and 0. It's got to be divided by 3. So I'm going to get 13056. So that's the moles of aluminium. And I can find the mass now. What do I need to do to find the mass? Multiply the moles by the AR, which is 27. So if I multiply it by 27, I'm going to get 352. So I'm going to get 352 and 530 grams. Okay, that's going to be my answer for this, and calculate the mass of aluminum. That's it. So मैंने पहले charge निकाला. From charge, I was able to figure out using Faraday constant. I was able to figure out the moles of electrons. Once I have the moles of electrons, I can use ratio 3:1, find the moles of aluminum, and then multiply it by the AR, which is 27. And once we do that, I'll get this, and this will be written as not this number. It will be written as 35. Okay, this number will be written as 350000 grams. Okay, which is I think 350,000 grams. ठीक है, you're going to round it off till the appropriate significant figures. यहाँ पे in the original values they were accurate up to 2 significant figures, so your answer cannot exceed 2 significant figure accuracy, so it has to be 350,000. ठीक है, और and that's it. ठीक है, अच्छा अब ये कि ये तो clear है ना पिछला, is that clear, the previous question? अच्छा नेक्स्ट पे चले जाते हैं. we've got ये पीछे किस तरह चले गए. अच्छा ये आगे फिर क्वेश्चन आ गया. अच्छा anyways I think we did this previously, but I'll just go through this question quickly. He said what is meant by the term standard potential. So it's a potential difference calculated between a standard electrode and a standard hydrogen electrode. Okay, that's what it meant. And he asked you to figure out to make the electrochemical cell between gold ions and gold and nitric acid and NO. So NO gas यहाँ पे थी, nitric acid was in the solution. You had a platinum electrode, gold and gold ions. The gold will be the electrode, right? So we made that. And then he wanted us to make an equation for the reaction over here. So nitric acid and NO and gold ions. So they gave us the table. Higher potential gains electrons, lower potential loses electrons. This goes forward, this goes backward, and we were able to make an equation for the reaction. And we were able to calculate the E0 cell for this reaction as well. Achha, next part पे आ जाते हैं. This one is more tricky. ठीक है? He's saying gold can be oxidized by a mixture of concentrated hydrochloric acid and nitric acid known as aqua regia. Concentrated hydrochloric acid is 12 mole per dm cube, and concentrated nitric acid is 16 mole per dm cube. Explain why aqua regia is able to dissolve gold. So this is what he's saying. कि जो gold है ना, if you use nitric acid and you use कौन सा acid, hydrochloric acid, right? And in very concentrated amounts. So he says that this is aqua regia, right? This entire thing is, according to the question, if you read the statement, this is aqua regia, right? And he's saying that aqua regia is able to dissolve gold. So the gold is able to turn into gold ions. It's able to dissolve that. So in your answer, state and explain what effect the use of concentrated hydrochloric acid and nitric acid have on the E values of half equations 2 and 3. So we have to look at half equations 2 and 3. So this is the question. Aqua regia dissolves gold, and we have to figure out how it does that, right? So, or specifically, he's talking about half equations. He's specifically talking about equation number 2 and equation number 3. He's saying explain your answer using these two equations, right? So starting with the first one, if I have concentrated hydrochloric acid, तो क्या होगा, ये जो Cl ions है over here, they will be concentrated, right? If the Cl ions are concentrated, where will the equilibrium shift? It's going to shift in the backward direction. It's very concentrated. 12 mole per dm cube कह रहा था वो. So it's extremely concentrated. So if it's very concentrated, the equilibrium will shift in the backward direction. And if it shifts in the backward direction, what happens to the potential? Will it become lower or will it become higher? क्या होगा when the equilibrium shifts in the backward direction? और ये पहला part clear है कि if I increase the concentration of Cl ions, the equilibrium will shift in the backward direction, right? So याद रखना, backward direction, it's going to produce a lot more electrons and it's going to become more negative. Let's give it a value. Let's call it, I'm going to get, let's say it becomes 0.8 volts. So ये idea clear है कि the potential will decrease. I just gave exactly more electrons are going to be produced, and so the electrode will have more negative charge. So its value will decrease, its potential will decrease. Instead of 1 volt, it will be a lot lower voltage. It's so let's call it 0.8 volts. ठीक है? ये clear है कि concentrated HCl use करने से what will happen to the potential of this thing, right? And similarly, what will happen if you use concentrated nitric acid? Now, nitric acid is H+1 and NO3-1. Now, if you use concentrated nitric acid, where will this equilibrium shift? This equilibrium will shift forward. If it shifts forward, the potential increases. So instead of 0.96, it will be, let's say, 1.20 volts, right? So it will be 1.20 volts. I just gave it a hypothetical value. You can remember, it's not just saying that it increases, right? So हमने ये पढ़ा था कि if the equilibrium shifts backwards and it produces more electrons, the potential decreases. If the equilibrium shifts forward and it consumes the electrons, the electrode will become more positive and it will be a higher potential. ठीक है? तो यहाँ पे हमने discuss कर लिया कि concentrated HCl के साथ what will happen and what will happen with concentrated nitric acid. So I gave the two reactions hypothetical value. Now, if this is 1.2 and this is 0.8, so the higher voltage is this one, and the higher voltage, what does the higher voltage do? It gains electrons, right? And relatively speaking, the 0.8 volt is the lower voltage. The lower voltage, what does it do? It loses electrons, right? So why does gold dissolve? Gold starts dissolving. It starts turning into gold ions. So it no longer remains gold. You've got a feasible reaction now. The higher potential gains and the lower potential starts to lose electrons. So the idea clear है why does aqua regia is able to dissolve? अपनी original values के साथ it was like if you look at the original values, like if you look at the original values, gold is not going to dissolve because this is the higher potential and it's going to gain electrons. So gold is not going to dissolve, it's not going to go back. So original values ke saath it wasn't happening. But when you use concentrated HCl, the equilibrium shifted backwards and the potential became lower. Or yahan pe when you use concentrated nitric acid, the equilibrium shifted forward and the potential increased. So the lower one actually became the higher one, and the higher one actually became the lower one, which is why the reaction was able to happen. So that's what you're going to explain. Okay, concentrated HCl, these are the words that you're going to use, pushes equilibrium number 2 or equation number 2 equilibrium to the left, and hence its potential decreases. And when its potential decreases, gold is oxidized, it loses electrons. Or vice versa, using concentrated nitric acid, it pushes equation 3 equilibrium as it pushes the equilibrium to the right. And its potential increases. The E0 value increases. Not the E0, sorry, this is non-standard condition, so don't use not. I'll just use E. Hence, it gets reduced. Because that's your 3-mark answer to this. And state and explain the effect and on the E values of half equations 2 and 3. Is this clear? Your question clear? The original values because this reaction was not going to happen. But when you use concentrated HCl and when you use concentrated nitric acid, the reaction did happen. Chalo, next one. ये calculate करें E naught cell for this reaction. So which, now they've given us the whole reaction. Which two electrodes make up this reaction? If you look carefully, there's copper 2 plus and copper 1 plus, right? So you got a copper 2 plus and copper 1 plus electrode. So open the data booklet and find the copper 2 plus, copper 1 plus. जो के कहाँ पे है? Let me up this. अच्छा, so the copper 2 plus, copper 1 plus, it's this one. So that is one of my electrodes, right? And what's the other electrode? It's I minus 1 and iodine, right? So you got the I minus 1 iodine electrode, which also must be कहाँ पे वो ये नीचे है, the iodine and I minus 1, right? So the reaction is happening between these two. And he's asking, is this reaction feasible or is it not feasible? Okay, that's what the question is. Now I have to carefully first look at it. Okay, where is the equilibrium moving? Copper 2 plus changes to copper plus 1. I mean, the equation states that copper 2 plus changes to copper plus 1. So copper 2 plus changes to copper plus 1. So this is reduction happening, right? And what happens to iodine? I minus 1 changes to I2. So that means this reaction goes in the backward direction, right? And this is my oxidation. So that's my oxidation equation. Ab mujhe batao, can anyone tell me, will this reaction happen? Who gains electrons? The one that has the higher potential, right? So 0.15, 0.54, this is not the higher potential. So it will not be able to gain electrons. Is that clear? Ye baat clear hai? Baaki clear hai कि this reaction is not going to happen. It should be the higher potential. That's why it gains electrons. But when we saw over here, it's not the higher potential. So how do you prove that this reaction is not feasible? You calculate the E naught cell. The E naught cell is, how is the E naught cell calculated? It's calculated use reduction E naught minus the oxidation E naught. So who was getting reduced? I think it was copper that was getting reduced. So that's 0.15. So 0.15 and the other one was minus 0.54. So the value again, this will come out to be minus 0.39 volts. And negative value indicates that it's not going to happen. This reaction is not going to happen. Okay, it's negative indicates that just direction when you're mentioning that the electrons will flow, it's not going to flow in that particular direction. Okay, the electrons are not going to flow in that direction. As I explained how the E naught cell calculator predict the reaction is not likely to happen because the E naught cell is less than 0. So not feasible or spontaneous. Or simply it's not going to happen. अच्छा फिर ये question आ गया कि about the Nernst equation. Now he's saying there's an experiment and a solution of I minus 1 is added to a solution of copper 2 plus. A reaction does occur. So it's the same reaction. A solution of copper 2 plus is added to I minus 1. And the reaction does occur and a precipitate of sparingly soluble copperized solid is formed, right? So he's saying that usne jab lab mein kiya na, the reaction is actually happening, this one. Although it's not feasible, right? अब वो कह रहे हैं the concentration of copper 2 plus remaining in the solution is 1 mole per dmq and the concentration of copper plus ions in the saturated solution is 1.3 times 10 power minus 6 mole per dmq. Use the Nernst equation to calculate the electrode potential of the copper. So the thing is, he's doing this reaction, but under non-standard conditions. ये कितना था 0.15 volts था. So he's doing this reaction under non-standard conditions where he mentioned copper 2 plus as 1 mole per dm cube. Take your calculator out again. And copper 1 plus is 1.3 times 10 power minus 6 mole per dm cube, right? So you've got this reaction. What is the Nernst equation? You have to find the new potential because this one is the wrong potential. This is the standard potential. So I have to find out the new potential. The new potential would be, it's going to be the old potential E naught plus 0.059 divided by Z, which is the number of electrons, log of oxidized species, which is the one on the left side. So that's 1 mole per dm cube divided by the log of reduced species, which is the one that's on the right side. That's 1.3 times 10 power minus 6. So use a calculator. What do you get for this? और कैलकुलेटर निकालो क्या है ये वैल्यू Adina, we're just ending a chapter, ठीक है? It's I'll message you. As a 0.497, you're getting 0.497 for this. So 0.497 volts, right? So are you sure? Hopefully it's the correct one, right? Lag raha hai it's going to be 0.497. So instead of 0.15, it's actually 0.49. It's actually going to be 0.497, right? So why is the reaction happening? Okay, instead of 0.15, although they didn't ask for it, but let me explain why the reaction becomes feasible. Okay, 0.497 hai. And maybe the ideal electrode slightly decreases. Let's say it becomes instead of 0.54, it becomes 0.45. So आप मुझे बताओ E naught cell क्या होगा? It's going to be a positive value, right? So the reason this reaction is happening in the real world is the conditions that he's using. These conditions, the copper 2 plus copper plus electrode has a much higher potential. Instead of 0.15, it's actually 0.497. ठीक है? ये वाला example clear है? Nernst equation वाला, is that clear? और ये हमने Nernst equation भी की थी. Is this clear? अच्छा, so चलो फिर ये कंटिन्यू करते हैं. We'll do more past paper tomorrow, ठीक है? Just more past paper questions. Just go through the notes, ठीक है? I've shared the link of the board as well. Go through the notes जो कुछ हमने किया, and we'll then talk tomorrow, ठीक है? And practice more questions. Remember, next week we'll start a new topic, ठीक है? So, okay, everyone. Allah Hafiz.